Hey everyone, this is Marcus, Dev Relations at Soulbound Labs. I am here with Goose, also known as his real name, Alex Gusev, and he is one of our back-end developers, experienced in subgraph development, experienced in a lot of the nuts and bolts of how our project works. So what I wanted to do is take a few minutes to chat with him, to have him explain Subgraph Bridge, both to me and to you, and what Subgraph Bridge unlocks. So first and foremost, Alex, if you could explain kind of what you've been doing and with Soulbound Labs, as well as a little quick what does Subgraph Bridge unlock? That'd be super, super helpful, man.
Yeah, for sure. So I guess like what I do at Soulbound Labs, I wear a number of different hats, but I do a lot of stuff. So I work a lot in the back end mainly. Sometimes I'll help out in the front end, but really a lot of the stuff I do is related to infrastructure and all the things that make the things happen. And yeah, I guess.
That's a perfect answer.
Yeah. And then, sorry, what was the second part of the question?
And so you've been working on the back end of things. Tell us about Subgraph Bridge, because that is quite back-endy, and I want to see what that means to you as a developer in the Web3 space.
Yeah, well, it means a lot, and it means a lot of different things, and I think it means a lot of things that I don't know that it means. Because really the potential ramifications of a pretty open-ended piece of software, and really, I mean, I would almost go as far to say this is a piece of infrastructure. It's pretty huge, because I guess the quick TLDR on Subgraph Bridge is you get to bring your Subgraph query results back on chain. And basically what this means is that you enable a brand new paradigm of smart contracts, which use these events, which are kept within transaction logs, as primitives to derive data from, which then can be bridged back on chain. And so I think that there's a lot of really, really interesting and weird sort of stuff that you could build with something like this, because again, like events are free to emit. They don't cost any gas to emit. And so you can really encode a bunch of data on the smart contract end of things, which you know is going to be correct within the subgraph, because the subgraph is pulling data from the chain. And so it allows you to basically offload a bunch of computation into a subgraph, which then you can encode the results again and put it back on chain. So that way you're using the chain as a consensus layer to make sure that this data is correct and, valid, but you're actually extrapolating a ton of meaningful data once you unencode that or decompress that information in some way within the subgraph, which then you could use on your front end or, again, within the contract itself. And so I think that it's a very, very interesting sort of way of opening up a new way of storing data on chain, because you're storing it, but then also kind of not storing it, because logs are just logs. They don't have like a state in the traditional sort of way. So I think it's a very, very interesting sort of idea and paradigm. And I'm excited to see what gets built with it.
That's amazing. I'm still trying to wrap my head around it. I know Connor's been working on it hard. I know you. Mm-hmm. This is really an incredible piece of technology. From the back end and, as you said, the infrastructure side of things, let's talk about the application of this. In first pass, I heard you say something about financial something or other in previous conversations, DeFi. What specifically could this unlock for DeFi?
It could unlock a lot of different stuff. There's
super creative. It sounds like you can, if you can go into the creativity that this could potentially unlock for DeFi and all the different ways it could go.
So I guess we're going to get a quick computer science lesson. So there's this problem in computer science that's called the halting problem. And basically what it means is that when a Turing-complete programming language executes a process, there's no way of telling if that process is going to halt or come to a complete. Such as, if I write a recursive function that just loops until I kill the entire computer, you have no way of understanding if that's going to be a recursive process and if it's going to end. And so this is potentially an attack surface for the Ethereum network. And so the developers of Ethereum came up with this concept of gas. And everyone knows gas is like the normal sort of sense. I am going to pay this much money to have this transaction go through because it does this much computation. However, within the context of some of these things, there's also reading gas. So if you're reading information from the blockchain, again, because of this halting problem, I can't tell you if I query this view function, which is free, if it's going to ever stop and give me back a response. And so included within the gas cost is also how much reading gas it does. And reading gas doesn't actually cost a user anything to use. But what it can do is if I have a fractal NFT, which is actually something that I built, and this is one of the ways that I became aware of this, is that if I have a recursive function and I'm doing some crazy fractal, which is, iterating over itself 1,000 different times, that's going to be so much reading that the system basically effectively cuts off. So there's a maximum amount of reading data you can do within a single call before most people and most providers put a cap on this. And they do this because, again, they don't want you really like DDoSing the system by just making arbitrary calls that will never actually return a value. And so like one of the really interesting uses of this is that you can simplify and gather a lot of data using a subgraph, because if you're using a subgraph, we know that, you built this and you're trying to extract all this data. And if it doesn't, if the subgraph doesn't work, then no one's going to index that subgraph. And so basically you can aggregate a seemingly infinite amount of data on chain within a single call and use that within your current smart contract that can do some other thing from that data, such as, I don't even know. It's super open-ended, but you could, I guess, like aggregate different prices or get some collection of daily volume within, 150 different tokens and do something meaningful with that data from, Jesus Christ, man. This is
it's everything. No, you're doing great. You're doing great. No, it's very interesting to me. I mean, I am not as technical as you. I'm doing my very best to learn, and learn I am just by talking with you. It's clear that the Graph has seen value in this product because they've invested their grant money into this product, and we're very excited for that. Thank you, Graph Grants. Awesome. We're very excited to get this out. And so for the Graph, why would the Graph find interest in this? Why would the Graph say, hey, I mean, it seems like pretty clear there's a lot of opportunities.
Yeah, and I'm going to give it a pretty simple answer. I'm going to really reduce the complexity there because like anyone can extract their data from here because really actually it can be like the importance of this can be said in a single sentence. So why is Subgraph Bridge important? Well, Subgraph Bridge is important for a number of different reasons, but the kind of TLDR and simple answer to that question is it allows you to utilize the Graph's network, the Graph's decentralized network, as a layer 2 for your smart contract. So you can store the bare minimum amount of important data on chain, and then within your subgraph, you can utilize that bare minimum on-chain data to extract some new meaning or do something else, and then you can store those results back on chain again in an encoded or packed form.
Super cheap computations. Really, that's awesome.
Yeah, it basically allows you to reduce the gas limit of a contract, and you get to reduce the gas complexity of a contract to really encode the bare minimum amount of data, put it into a subgraph, and then verify those results back on chain, which is super, super powerful. There's a lot of really, really cool stuff you can do there.
Very cool. So basically a subgraph dev becomes incredibly powerful.
Yeah, because it enables you to use a ton of extra computation power that you just wouldn't be able to get by storing by doing all this computation on chain.
That's awesome. Yeah, I mean, Subgraph Dev's already such a backbone part of the Web3 space to be able to get the blockchain data that they want and then actually put that into dApps, analytics and such. But then to actually get that data, run computations, and then put that back on chain, that is super cool to be a layer 2 in using graph infrastructure. Is that basically what you're saying there, Alex? Am I getting that pretty right?
Yeah, exactly. Yeah.
Well,
just offload computation.
That's
which is cool.
amazing. That's amazing. So we're very excited to get that out very soon. We hope. We hope very soon. We're doing our best, but we should have something out relatively soon. Thank you for your time, Alex. I'm really excited for this to be out there in public, to give the public, give the devs the power of the graph and being able to have that computationally brought back on chain. It's really, really cool paradigm for a zillion things to unlock a lot more use cases for Web3, which is very much needed. So anyways, man, is there anything else that you'd like to share before we sign off here?
I don't think so. Yeah, no, I think I did my best to explain it in a non-rambly way. So we'll see.
It's good. It's good.
We'll see how that goes. But
no, this is good. This
great.
is good. Yeah. Well, yeah. Thank you for your time. Thank you, Graph Grants and the Graph, for your support in this project for the Subgraph Bridge. And take care, everyone.
See you.